Okay, guys, today we're going to work on solving exponential functions and logarithmics. Let's see here. There's a couple different methods that we're going to use. One of them you've seen quite a bit this week. The first one is that same base rule that we keep talking about. Which is actually known as the one-to-one property. Okay, again, has nothing to do with a horizontal line test, nothing to do with the inverse or anything like that. But if I can get a same base, you know that things will cross out. So let's just look at a couple of examples. One that I've showed you a lot this week is something like 2 to the x equals 32. So if I can write both sides with the same base, then these guys here will cross out. And we can just set the exponents equal to each other. Now another example, it's a little different. We haven't seen one like this yet, I don't think. But sometimes you can cross out the logs. Let's say you have log 7 equals log x minus 5. Here, if I have a log base 10 on this side and a log base 10 on this side, then that means 7 equals x minus 5. If these are equal, then this number here equals this number here. So we don't even need these as long as they're the same base. They're both common logs. They both have the same base of 10. Then we can just say that 7 equals x minus 5, and you can solve from there. So on that one, we crossed out the logs. Now, anytime you're solving a log equation, because we do have restrictions on the domain here, you want to make sure that your answer checks. You want to make sure that you get a positive number. Remember that this cannot be 0, and also it cannot be negative. It has to be positive. So make sure that you're plugging your answers back in. So we'll just check. Plug that 12 in. And as long as you get positive, you're good. We get a positive 7. Okay, so that's using the same base rule. Now, another method is using the inverse. Okay, what I mean by that is you're either going to change the problem from exponential to log or vice versa. So let's look at a couple of examples here. Let's start simple. We'll say e to the x equals 7. Remember, we can take the base here and slide it over, and it becomes a logarithm with a base e, which would be a natural log. Or I've also taught you that you can just take the natural log of both sides, and because you have the same base here, that little e down there, these guys will cross out. So you end up with x equals natural log of 7. Okay, so if you're not able to use a calculator, then just write your answer with a log. That's no big deal. If you are given a calculator, you can go ahead and plug that in, and we would get 1.946. Anytime you're using a calculator, it's best to go ahead and round to at least 3 decimal places. So either one of those works. I know many times on your quizzes and things, I don't let you use calculators, so just leave it in terms of log there. Okay. Let's look at one where you change it from a log to an exponential. Let's say you have the natural log of x equals 3. Remember, you can slide the e over and make that e cubed, or we can give both sides a base of e. So that will cross out. And you get that. So no calculator, that's a great answer. If you have a calculator, you can say 20.086. Just depending on the situation. Okay, good. So there's your two methods. Same base rule and then using the inverse. Now I'm going to run through maybe 3 or 4 more examples. So let's do that. So let's solve. The natural log of x plus 2 equals 2. I'm going to use the inverse. I'm going to change it to an exponential. So I'll just give them both a base of e. And we end up with x plus 2 equals e squared. So final answer, e squared minus 2. Because I started with the logarithm, you want to make sure that you check your answer. So if I plug that back in, plug in that e squared minus 2 for x, and you can see that I end up with the natural log of e squared, which is a positive number, so you're good. You're good, it checks. Okay. Let's keep going. E to the x plus 5 equals 60. Here I'll isolate the exponential. So we get e to the x equals 55. Now I can just take the natural log of both sides. Again, the reason I'm choosing a natural log here is because the base of the exponential is e, so I need a log with the base of e, and that would be a natural log. So that crosses out, and we get x equals the natural log of 55. If you're using a calculator, you can plug it in, or again, you can just leave it like that. How about this one? Let's do 5 plus 2 natural log of x equals 4. So last time we were isolating the exponential, now we want to isolate the log. Okay, so if I subtract the 5, you can move that to x squared if you want, or you can divide it. Either way, it'll work both ways. So here I'm going to give both of these a base of e. Let's go up here with it. So I end up with an x on the left side because it crossed out. And I get e to the negative 1/2. Now, make sure you check because you had a logarithm. When I plug that e to the negative 1/2, which is a positive, let's see, the negative just puts it on bottom, and then the 1/2's a square root. So really you're just looking at 1 over the square root of e, which is positive because you know a square root's going to give you a positive. So, you know, the 5 and the 4 and the 2 there, I mean, none of that even matters, just as long as inside that logarithm you're getting a positive number. So that one checks. So your answer is just e to the negative 1/2. I know I'm going crazy with examples here, but I just want to show you all types. So we're just going to keep going. Let me show you some where you start to use the properties now. Let's look at log base 6, 3x plus 14. So it's a log problem, so you're going to want to make sure that you check your answers. Minus log base 6, 5, equals log base 6, 2x. Okay, let's condense this down to a single logarithm. So using the quotient property, we can take it from a difference of 2 logs to a quotient. Like that. And now we have a log base 6 equals a log base 6, which is always fun to get rid of the logs. And we have 3x plus 14 over 5 equals 2x. Definitely want to get rid of the fraction, so we'll just multiply both sides by 5. So that crosses out. Multiply this side by 5. And I get 3x plus 14 equals 10x. Subtract the 3x. And then divide the 7. Make sure you check it. So if I check it over here, when I plug a 2 in there, I get log 2 times 2, which is positive. And then make sure you check it here as well. Every log in the problem. So 3 times 2 is 6. Plus 14, so that one checks as well. So your answer is 2. All right, let's see. We're 16 minutes in. I'm going to do 2 more. 2 more toughies. Okay, let's do common log of x plus 4. Remember my base is 10 there. Minus common log of x equals log x plus 2. If I condense this down, I get a log equals a log. So we're looking at x plus 4 over x equals x plus 2. Get rid of the fraction, so I'll multiply both sides by x. So we end up with x plus 4 equals x squared plus 2x. And we just created a quadratic. So let's set this equal to 0. I'll subtract the x over here. And I'll subtract the 4. Does it factor? No, there are no factors of negative 4 that add up to a positive 1. So let's let's slide over here and use quadratic formula. So x equals, I'll go ahead and write it out for you. There you go, negative b plus or minus b squared minus 4ac, the square root of b squared minus 4ac over 2a. So let's plug it in. So my b is 1, so we're looking at x equals negative 1 plus or minus the square root. B squared is a positive 1 minus 4, 1, negative 4. So we're looking at a negative 4 times a negative 4 is a positive 16. Plus that 1 is a positive 17. So here's the question. Are we getting 2 solutions for this problem? Okay, well, if you think about it, square root of 17 is approximately 4 point something. And negative 1 plus 4 point something is going to be positive, where negative 1 minus 4 point something is going to be negative. So is there any place up here where you just cannot plug in a negative number? It would be right there. Okay, right there where it's just log x. Negative 1 minus 4 point something is a negative 5 point something over 2. That part right there will make it undefined. Whereas a negative 1 plus 4 point something, so we're talking about 3 point something over 2, works for both of these and this one. So our only solution would have to be x equals negative 1 plus and only plus. Okay, if you were to set that equal to 0 and plug that in your calculator, you would only see one solution. It would cross at that number, negative 1 plus square root of 17 over 2. Okay, told you it was ugly. But I've got one more for you. Last one. And then you can just go to work on your homework, page 218. This is a weird one that will show up a couple times. So 2 times e to the 2x minus 7 times e to the x equals negative 3. You need to look at this like a quadratic here. Okay, you've got that e to the 2x. Let's go ahead and set this equal to 0. Now we'll solve for x. But believe it or not, this does factor. If you multiply your a times c, you get a 6. You need 2 factors of 6 that add up to a negative 7. That works. Negative 6 and negative 1. Divide by a. And then reduce. Okay, so when you're writing your factors here, instead of 1x minus 3, it needs to be e to the x minus 3. And then the other one needs to be 2 times e to the x minus 1. Now, it's a little confusing how I got that, but instead of this being x squared, you can almost think of it as e squared. I mean, it's e to the 2x, but if I multiply these two back together, 2 times 1 is 2, e to the x times e to the x, you add your exponents and you get e to the 2x. Just like that. The outside would be a negative e to the x. The inside would be a negative 6 e to the x. So negative e to the x plus a negative 6 e to the x is a negative 7 e to the x. Negative 3 times negative 1 is a positive 3. Okay, so when you multiply it back together, it does check. Now just take each one of these, set it equal to 0, and solve. Okay, so here I would say e to the x minus 3 equals 0. E to the x equals 3. Take a natural log of both sides because I'm dealing with the base of e. So I need my log to have a base of e. And you get x equals the natural log of 3. There's one of your answers. We don't need to worry about checking this one because we're dealing with an exponential. If I was a log, I would want to make sure to check, but don't have to worry about it here. On this one, we can add the 1, divide the 2, now take the natural log of both sides, crosses out there because your bases are the same, and we get x equals the natural log of 1/2. I mean, if I ended up with a natural log of a negative number right there, then that would be extraneous. You would cross through that. But this one has 2 true solutions. Okay? So that should set you up for page 218. And don't forget, you have a quiz over solving tomorrow. Good luck and have a good rest of your day. Thanks.